Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look again at the use of command line parameters when launching applications. Within your applications, you may require at the beginning of your application to pull in information from an external source. This could be from a configuration file or a command line parameter. Today we're going to specifically look at command line parameters, and we're going to create not one but two applications. A main application which will pass information to a called application. This second application will accept command line parameters. In order to make this clear on screen, we're going to use both the Windows compiler and the console compiler. So on our screen at the moment we have two PowerBasic IDEs. The one on the left is the Windows compiler and the one on the right is the console compiler. Both of these compilers can accept command line parameters. One of the reasons for having command line parameters is your application may well be generic. This generic application will change what it needs to do based on the parameters it receives. As such, your application may be called from a scheduled task. When calling scheduled tasks, one of your options is to give it parameters. This way, your application can perform different tasks dependent on the parameters passed. So what we will do in the Windows compiler is we will use initially the shell command to launch our subsidiary application. So first of all, we will create a local variable to hold these parameters. And we will populate this variable with the words test and the numbers 1, 2, 3. When using the shell command, you have two options. You can run the command as a function or as a statement. If we're running it as a function, then processing will continue immediately on the next line of code. If you're not calling it as a function, then execution in your main application will be suspended until such times as the called application completes. But today we're going to call it as a function. We've created a local variable called process ID. The return from the shell function will be the process ID which Windows has allocated to your called function. And we're going to call an application called ccalledapplication.exe, passing at the end our parameters variable. We can then test the value of process ID to see whether it is 0 or not 0. If the value is greater than 0, then the process has been launched successfully. If the process ID is 0, then Windows has been unable to either launch or find the application you are looking for. The first parameter of our shell function is exepath plus the name of our executable. This gives Windows a direct path and name of the application to launch. If we excluded exepath and just gave it the name of the executable, PowerBasic and Windows would first attempt to find the executable in the folder which our application was in. If it did not find it there, it would then attempt to look in one of the Windows folders. And after that, if it still did not find it, it would start to look down the environment path. So in order to ensure that you find the correct executable, it's always good to give the direct path to the file that you wish to execute. So now that we've created this process to call our application, we need to create it. So in our called application, we're going to change the color on screen and print out the message application called and the time. We're then going to call a function called basic parameters. This function will take our command line information and display it on screen to ensure that it has been picked up correctly. And after that function is completed, we will display the words press any key to exit and use the wait key command to wait for a button to be pressed on the keyboard before ending the application. So let's now create this basic parameters function. And here is our basic parameters function. We're declaring a local variable called parameters, and we're populating that using command $. Command $, is inbuilt to PowerBasic and will return details of anything on the command line which is a parameter. We're then using the stdout command to display this on the console. So we will compile both of these applications. Now that both of these applications have been compiled, we can now launch the command line parameters executable. It should then call the cc called application exe. So let's run those now. So there is our Windows application at the top here, which is passing details to the called application. And within our console window, we have the word test and 1, 2, 3, which are the command line parameters. So we have succeeded in calling an application and passing it details on the command line. So let's see if we can take this idea a little further. We're going to create another local variable as a number, and we're going to populate that with the value 99. We're then going to add that number to the end of our parameter string. We can then compile the Windows application, and we should not need to recompile the called application. Let's just run the Windows application. And we can see in our console application, we now have test 123 99. So we can pass text and numbers quite happily on the command line to our called application. So just how much information can we actually pass on the command line? So in order to test out just how much information we can actually pass on the command line to our called application, we've increased the amount of data sitting in the parameters variable. And within this text, we have a large number of periods or decimal points. And we're printing this number using the tally command out to our log. So our calling application can report how many blocks of text it's sending to the called application. And in the called application, we're using the tally command again to print out the number of decimal points that it receives in its incoming parameters. If we try compiling our applications now and running them once more, we will see that our Windows application has 30 blocks of data. However, the called application has only 16 blocks. So we obviously have a limit on the amount of text we can pass on the command line using the shell command. This is not a PowerBasic limitation, this is a limitation in the Windows operating system, as the shell command is using under the hood a Windows API call. So we need to get a little bit more creative if you have a large amount of text you wish to pass as parameters on the command line. Here we have two options. You could put all this information in a configuration file, and the parameter you pass would be the location of that file. The other option is to use a different Windows API call, and that's what we're going to do here. We will, for the moment, in our calling application, comment out this block of code. And we're going to use a function within one of our libraries. So first of all, we will declare a local variable for our command line, and we will populate that with the path to our called application, putting a space at the end of this string. And we're going to populate our parameters list. In this case, we're going to be passing 4 distinct named parameters. And we're naming them using these strings. We have a name parameter for the file name path, one for the legend, one for data, and one for title. You can create as many of these named parameters as you find necessary. And the naming is case independent. After the name of the parameter, you then have a double quote, the string that you wish to pass, and then followed by an additional double quote. Now that we have both the command line and the parameters set up, we can now call our new function. And our new function is called execute command. It takes 2 parameters. The first parameter is our command string and our parameters, and the second parameter determines whether we show a console window or not. When you call your called application, you may find a need occasionally to have no console window showing to the user. If this is the case, just do not put this second parameter, as the second parameter is optional. If you use the create new console parameter, then a console window will be created and displayed to the user. In a moment, we will have a look at that function to see how it works. But before we do that, we're going to change our called application to be able to accept these named parameters. So let's comment out this basic parameters function and replace it with a new call. And we will call this advanced parameters. In order to make use of this new facility, we're going to have to include a new library into our called function, and that is the PB command line library. So let's now create this new function. The function starts off much the same way the previous one did. We're declaring a local variable called parameters, and we're populating it using the command $word. So that will pick up the entire command line string. We know that there are going to be 4 parameters passed to this application. 1 for the file path, 1 for the legend, 1 for data, and 1 for the title. So we have created 4 local variables into which we're going to put this data. And in order to populate this variable, we're going to call a new function, the return named parameter exp function, which is the only function within this library we have just added. This function takes 2 parameters. The first parameter is the name of the parameter we're going to be picking up. In this case, the slash file name followed by the hash. This is intended to make the name of the parameter unique. You don't have to use the slash or the hash, but you must use something that is unique in the command line. The second parameter is the name of the variable containing the entire command line, in this case parameters. And having populated this first variable, we can then populate each of the other variables using a call to this new function. 1 for the legend, 1 for data, and 1 for title. And now that we have those variables populated, we can now display them on the console. So we will compile this console application. So now that we've run the application, we can see that the called application has now picked up all 4 of these parameters: a file path, a legend, data, and then title. Having name parameters passed to your called application makes life for the programmer much easier, as the order that the parameters are passed is completely irrelevant, as you're picking up the parameters by name. It also means if you need to add an extra parameter, this can be quite easily done by a minor change to the application. And as you can see, in our data variable, we have a list of numbers which are pipe delimited. So even some of your parameters can have sub-parameters. So let's now have a look at that function within our new command line library to see how it does this. If we load up the command line library, you will see here is the single function within this library, taking its 2 parameters, the name of the parameter and the second variable, which is the command line string containing all of the data passed for all of the parameters. To save confusion, this is set to allow case-independent command strings. That way, if your calling application has a different casing to the name of the parameter, this will not matter to the called application. And we're using a number of string commands to work out where in the string our named parameter actually appears. And we're then using things like the mid$, right$, and length commands, as well as the parse and remove string commands to chop up the command line string and give you back the population of that specific named parameter. Should the parameter not be found, it will return an empty length string. So this small piece of code is exceptionally useful when it comes to handling named parameters. So now that we've looked at that, let's look now at the execute command, which is called as an alternative to the shell command. This function is in the PB shell library. There are a number of functions in here, but the one we're going to look at is execute command. It takes two parameters, the second of which, as you can see on screen, is optional. If the second parameter is not given, then the application will assume you wish to have no console window displayed to the user. We're then calling a Windows API call called createProcess. If the return from this createProcess function is 0, then we have been unable to start the process, and the function will terminate immediately. The next part of the code will determine our timeout. How long do we wait for the called application to complete? In this case, I have it hard-coded for -1, which means it will wait forever. Since we know the application is started, we will wait till the application is no longer in memory. This value is expressed in milliseconds. If you prefer to wait for a certain length of time to ensure that the application you have called is not looping, then you can amend this application to change this parameter to a suitable number. The advantage of using this function as opposed to the shell function is that you're not limited in the number of characters passed in the same way that the shell function is. There may well be a maximum limit on the number of characters this can handle, but to be honest, I've never encountered it. So in summary, what we've achieved today is we have created two applications. A calling application which passes parameters to a called application. We have created the calling application in PowerBasic for Windows, and created the called application in the console compiler. This was done to make it easy to tell the difference between what was calling and what was called, but the same code will work in either the Windows or the console compiler. We have proved that the shell command, while it does work well, has its limitations on the length of command line string it can take. We have used another Windows API call using a function in our shell library. We have also changed the application to use named parameters, again using a function in one of our additional libraries. This gives you more flexibility and indeed makes your code much more readable. Hopefully you'll find these techniques useful in your applications, but that's it for today. Thank you for watching.